Namaskar. This is Engineer Suraj Singh, professional engineer in Bharat. Many of you know me as I have been giving many videos for many weeks. Now I'm starting another series, that is civil engineering building practice. It is based on my experience in Middle East Gulf countries, and I have written a book. Wrote a book in 1996 that was published by CBS Publishers, that being Civil Engineering Building Practice. You know, it's based on exclusively practical experience, how a civil engineer works in the field, particularly building projects. I'd like to give you certain contents of this book so that you get apprised yourself how it works, how it is given. You can see the cover I have shown you before now. Civil Engineering Building Practice, and this is a group of buildings here shown, and these are the contents. And books are project management, state-of-the-art contracts, new site schemes, structural profiles, swimming pools, baths, engineering law with statutory references. And this is CBS Publishers and Distributors, 11 Rayaganj, New Delhi, 11002. If you see the contents of this book, it will be very clear. This is about the publisher. I will not take much time on this, and I'll go directly to the contents of this book. The contents are: number one is categories or classes of planning, explanation of classes, preparation of various bills of quantities, preparation of various building specifications, converting the above documents to tender documents, shortlisting or pre-qualification of tenders, floating tenders, closing, scrutiny and negotiation, tender bond, site handover, commencement of construction, supervision and control by various agencies working in the contract area, coordination, liaison, contractors, organizations, structures level, contractors agent, internal dealings with contractors, organization and dealing at site, elaboration of coordinations as pointed out earlier, architectural structural coordination, structural mechanical engineering coordination, electrical mechanical engineering coordination, reflected ceiling plans, structural finishes, electrical, structural, plumbing and drainage, services finishes, external services, external works, liaison to the statutory bodies, structural and structural. Liaison, main contractor and subcontractors, subcontractor and subcontractors, main contractor, resident engineer and engineer, contractor and other main contractors, main contractor, local statutory bodies, main contractor, engineer. Then there is what a contractor agent is supposed to do: maintaining site diaries. Some consultants prefer daily job records, daily job submittals, material submittal, pro forma sheet, etc. Then shop drawings, working drawings, pro forma, weekly program, quarterly program, complete program, bar schedule charts, allocation percentages to a particular activity, operation, revised programs, monthly progress reports, monthly technical and coordination, and so on and so forth. There's a long list of contents in brief in this book. It will take many minutes to explain all, but at this stage I'm just briefing you what the book contents is, and it is helpful for particularly those engineers who want to work inside and the graduation. Now, there was a direct circuit of this management, you can say direct course of building practices, management circuit. This is system diagram I have given here. Key plan, how a small project can be managed in a key circuit here. Various officers, various engineers, various levels of contractors, client and consultant are given here. This is just for indication purpose. Nowadays there are so many officers have been added, but this was long back. For the purpose of refreshing I am giving here. And there is a management structure here. Further, you can say this Maybe it's not clear because it's a very old book, but it's good for education purpose. In a kind of mini organization chart, only by the lines, not using by organization software Excel sheet. I'm just giving directly from the book. So just for the purpose of your information that so many engineers from various parties are utilized or were utilized in the field, and then the building contents have been started here. But before that, I'd like to give some diagrams which were used, which were included in this book. And these are very important to you people, at least for having a direct understanding of the field. I'll give you some practical diagrams here before going further, so that you understand well. And this is a plate. This is black and white now, in black and white, but this is the plate of showing a site of building, that is construction of a big school, boys preparatory school. This was in Doha, at Salal, Doha. It was in 1986. You can see the preparatory works have been going on for slabs. In this, you can see, I'll explain to you, I'll narrate to you what is written on the plate so that it's informative to you. It says description of the enclosed plate is preparatory formwork for suspended floor slabs in progress, columns poured up to beams of it level, approximately a few centimeters below, centering and form material lying up around, one slab ready for pouring, one slab ready for pouring and being given final touch for the purpose of pouring. Concrete mobile pump taking position by adjusting the pump boom. And its own body to cover the maximum area of the proposed pores without shifting the station if possible, but not necessary. Rock breaker machine excavating the rock area, and you can see the site is looking a little untidy because scaffolding material lying here and there. It should not be like that, but it was like that. And you see the here, you can see this a pump here, crane, some columns, and let's go to the other plate now. This is so the same site, and the work for preparation and getting the slab ready for the purpose of pouring by using a reciprocating pump. This is the pump. Also, this is the pump machine, and a transit mixer is offloading the ready mixed concrete to the pump. It's getting ready for that. I hope you will like this. And these are some rebars seen here, visible here. And I'll shift to another one. This is the next plate. This plate, which is actually pouring the concrete on the previous slab that I explained to you. I indicated is there. It's pouring there. You see the gangs of the people, gangs of the workers are standing here on the roof, on the slab, and all mesh you can see here. Certain small columns projecting from the slab itself for small purposes, and this all mesh here. And white color, you can see these are the electrical conduits passing through the slab embedded. And here the gangs of the people holding the pipe, chute you can say. This is the chute from the boom, and this is the boom of concrete pump, and this is all here. It's very important from understanding viewpoint that how the work is done on concrete pouring. Go to the other plate. You see, this is an indication of the site. You can see again the pump is here coming, and this is one part of the building. This was actually an auditorium type. Then there's a workshop type, and this side is classrooms. Here lecture halls, etc. And site is looking better, tidy. Then we go to the other plate, which is in fact showing certain columns. You can see like this, so the direction comes better. Columns here, only cast two columns. And here's a boundary wall, compound wall, long compound wall of the school here. This is just for the information how the works go on site. At least junior partners must know. Maybe seniors don't accept because they know this is just very bad, untidy site. But practically it happens on sites. It was very old in 1986, 87. In those days, quality was not that much formally, but site agents used to do all the jobs, quality, etc. Here you can see myself standing in cap, blue cap. If you see the blue cap person, so it's not blue here, but it is here. You can see this person. Who this is me, I, and here is the concrete chute. You can say disposal from the boom. There is a disposal from the boom here, and you can see the concrete down on the slab. There are many people standing here, many workers, expert workers who know how the concrete is done. And this is the laid concrete, immediately laid and roughly finished. Okay. And you can see the beams here waiting for the concrete, and all rebars here waiting for the concrete. These all conduits, electric conduits here. If you go to the other plate, that is some site like same site, but you'll see certain manholes here, and this is the grade slab. This is the grade slab on which we are finding certain fabricated items of formwork, and these are the rebars of the. You can see the rebars, can't you? These are rebars here, all various rebars of columns. Again, other side boundary wall. You can see all these columns are ready for further works, and some excavation of drainage line, sewer line, you can say. And you see these are some blockouts here. These are the blockouts in the grade slab. These are all blockouts for services purposes. And let's go to the other plate. It's like this. You can see this. And there is a part project here. There's a tower crane. This is the pump here. And another part of the project showing the same. And let's go to the building with some mosque foundations. We have to construct a mosque. It's that one. It's the mosque. It's a mosque. We had to request one Maulvi, or you can say Imam, from the mosque, from institute, to set the layout of this mosque according to the direction facing west or facing Mecca, and it was done accordingly. You can see the isolated footings here and stiff beams, stiff footings here. This is how that. You can see the soil, like what type of soil you can see yourself. This is a little soft rock type soil. This is rocky soil. It's not soil. It's not clay. It's not sand. It's actually limestone rock. And you can see various machines here, the local machines from various sources we have taken just for the purpose of your reference. And I'll show you certain sketches now. You can see there's a drawing. There's a drawing which is showing you various foundations here. Various foundations here, showing the grids on both directions. The general practice to use grids on the drawings, and column locations are shown on those. And you can see here, this is for the purpose of formwork. Means you see this is the slab top, the slab. How the beams are shown, slabs are shown, the grids are shown, and this is, you can see, this is showing the layouts actually, setting out layout controls, how the layout is to be done. The field where to take references from the grids in both directions, the x-axis and y-axis, for locating the elements and members on sites practically. Similarly, it's a different type of structure. There's a different type of structure here, little L shape. Building is like L shape and various footings are there. And how the setting out is done, the spacing is generally 5 meters on both sides, both directions. And this the setting out how it is done and shown on this. It's too easy. Similarly, the slab setting out is there. Same means it is shown foundations, level and slab level. Just for the purpose of information, how practically it is done. For the purpose, it's just for purpose of indication. I think it may be useful. Let's say another one. It's a different one. A little cross type. See various columns of the grids. These various columns and beams and their spacing 5 meters in general. It's in general, means there's not hard rule for that, but in general. Consider that. And then another one, it's the same but slab level. The slab level. I have written certain notes, but that were typed those times. This was no computer actually. It is manually done. It was manually done, so it is not that clear. In those days, I used to do manually everything, and it's all drawn by hand. Nothing was for the computer. It's an inclined building with the grid, horizontally inclined, but L shape. Same type of procedures for the same type methods for purpose of references, and the slab again. You can see the same slab level. It may not be clear in this for the purpose of reference, but for the purpose of understanding, it can give an idea how the work is done in the field. Now let's see another complicated one. It's here. You can see it's little tedious. You see this shape of the building. It's little tedious. See the corner at one side, at one end, then another like that. It depends upon the architectural building, but the layout system is clearly shown, clearly indicated. I think you get it. Is it? Then let us see the slab location of that. Is the slab simply reflection of that one. If you see both, this is the both, and let's go to the other one, a different shape. This is Z shape, or you can take it like this, Z shape. Anyway, it doesn't make a difference. You can take both ways. And the grids are shown on both sides. both directions, x-axis and y-axis, and it is 5 meters of almost 5 meters, which is a typical pattern for better designs, for good designs, because more than 5 meters spacing doesn't work very nicely for ordinary buildings of RCC. For structural steel, that can be more, that can be 7.5 meters. And let's go now. The same reflection on the slab. You can see the same reflection on the slab. It's the same reflection of the slab as typically I showed there. And it's another building complication now. Let's see. A Z diagram, we can say it's like that. It's a little different now, completely different. Of course, complicated, but buildings happen to be like this. You can see the locations almost as usual. I have been projecting. Now, you see this is a procedure of setting out. Nowadays, setting out is not that difficult, but understanding is a must. If you don't understand, it will cause a problem. And surveyors, land surveyors shall try you all the time. They shall test you all the time. But you must know at least the basic principle, how it is done. Once you get the idea, it will be better for you people. Now coordinate system works. So coordinates are set on site. And you can see the slab of that. This is the slab layout of that. This is also with a similar pattern, as I told before. And same type of notings, same types of grids. Here, see the grids, 5 meters, and it is means an indication. It could be 6, it could be 5. And now I'll go to other one, which is a formwork arrangement. Let us see, there's a column. There's a column here. See, there's a column here. This arrangement of formwork column in plan. It's a formwork arrangement of this column. You can see how I put in the plan, how I reflected. Reflect this, suppose, first of all, you can see there's the ply here. There's the ply. You can see there's the ply here. Initial work is ply. This is a ply. This ply will really support the concrete, touched concrete. And you see this hanging stone here from the top of the shutters, top of the column shutters. This is for checking verticality at 3 points, because this is about 3 to 4 meters high column, and it requires 3 locations for plumb checkup. And you can see all these members around. There is a frame, cross frame of timbers. There are vertical battens. There are vertical battens here. These are the vertical battens. Very well you can see. These are the vertical battens. And horizontal and vertical supports that clearly give an idea of complication of the arrangement that has to be done on site for the purpose of resisting the horizontal forces as well as vertical forces. Vertical thrust as well as horizontal thrust means when concrete is liquid, the shuttering has to behave to resist the liquid force, that is WH cube over 6, that is a moment, and WH square over, it acts actually, the resultant acts at the 1/3 from the bottom of the shutters. At 1/3 the resultant force will be there, and there should be strong support which can resist the bending moment coming from the concrete when it is wet. After getting dry, there will be no problem. So the design has to be done accordingly. It's a little complicated and direct formulas cannot be applied, but it's not that difficult as well. Because it will take at least 1 hour or 2 hours. By the time it will be a little hard, it will set, and the pressure on the bottom portion will reduce. Pressure on the middle and top portion shall remain higher. Accordingly, supports are placed. You can see I put checking arrangement also. You can see this dotted line, access line here, and then there are 1 meter off certain lines from where measurements can be checked. About checking, the setting out of the column. You can see now in elevation the same. You see this is the column and this is the concrete on which it is supported. I've shown in one go, but practically it's not done in one go. Just for the purpose of indication, I have taken this together. Blending concrete I have taken here, which is foundation blending, and then I have taken concrete of the footing, which is in here. This is the concrete of the footing. This line is for footing concrete, and above that it is the concrete. Forms of the column. You can see the horizontal lines. These are the shikanja type. You can see clamps, steel clamps, and this timber lines in shade. You can see black shade, and hatching, cross hatching. You can see these are the cross timbers. And I have seen other lines such as single lines supports I have written there. These are like this. I have not shown full timber here, just locations I have shown for the purpose of understanding where the timber supports would come, bracing would come, just for the purpose of. Similarly, I have shown here in the foundation, just to let you apprise means how it will be done. It's a section actually. I'll go to another one, which is also a column with the same details to lesser scale and locations of these foundations, just for the purpose of reference and nothing very special. Now let us see the full scale of this column forms, because I'm just zooming. These are column forms from top here. It's very easy to see. Of course, it's not that in depth clear, but you can see yourself how the supports have been arranged and placed and pegged in at the bottom on both sides, on 4 sides actually, and more details are given in this that can help any engineer or any supervisor or any foreman to calculate the material required for the forms. You can see this plumb bob as well, and what all should be there. In advance planning can be done, real planning. You can see this is the clamp arrangement here, how the clamps works. You can see this clamp here, cross clamps, steel clamps, cross clamps, wherever this clamp line is shown. And now you see the elevation of this column formwork, which is of course a little complicated but easy to understand. It's giving the same types of details as I showed to you here before. Now, same, just is a question of reflecting or projecting, just like we do the building elevations in architectural work. It's another kind of architectural work. So simple it is, but it takes time if you draw for the purpose of shop drawings. Similarly, here, same kinds of drawings, but grids are shown at various places. Is the floor grids showing various elements, columns particularly. This is very important from the viewpoint of understanding. And you see another same part of the floor. You can see these cross columns. There was before the rectangular columns. Now it is cross columns. This for high rise. There is these columns for including a high rise building in Baghdad in 1982, and there are big fascia for the faces concrete from 4th level to 18th level. This is a very, very complicated building we had experienced, and we were supervised by a very, very specialist person who used to check each and every detail. Now let us see the column in further details. This is another detail of a considerable size column. You can see that. Supporting arrangement, you see the most important here is supporting arrangement. That's what I want to stress on you. It's practically how it is done. We have seen, we know in the books, but it's not available anywhere. Important thing is to understand the arrangement. That is most important. I just intend to stress on the new engineers particularly who have to face the carpenters, who have to face foremen, and who have to face many other artisans in the field. They should face successfully. They should learn from them as well as they should not indicate that they don't know the job. That is the most important area. Yes, engineers should help themselves without telling others that I am learning from you. This is what I want to indicate here. Same type of arrangements, but in details, elevation and details. I had to do all this by hand myself because I didn't know computers. Again, I'm telling just for those. Okay. You can see the arrangement L-shaped column, corner column it is. Same type of arrangements, but locations of members is different. As routine it is, but you will apply little thought process, how the arrangements can be done so as to allow the shutters to be removed also conveniently, not to waste a lot of time on them, and not to wait a lot of time, not to invest a lot of time on remaking of the shutters. Because once you remove the shutters, you have to remake them for the next stage or repetition purpose. Similarly, here is a very complicated arrangement here. You see, you can see the complicated locations of the vertical and horizontal members. But this is what is seen after the work is done. If I had direct photograph, I would be lucky, but I don't have that because this was a control building and photographs were not allowed. So I did all by manual reformations, manual reproduction. Unfortunately, I have worked mostly on the projects which are army controlled. There's another elevation here. Maybe you feel bored I am showing you all this nonsense, is it? But it is practical work. It gives some benefit to everybody. Maybe or may not be, but I think it will help you guys on site, or at least understand the complexities. And again, same type of column with many details. It should be helpful for you guys, dear friends. It's not that. Well, you may feel bored every time showing all repetitions. No, it's not repetitions. It's different types of arrangements. See, actually these are there's some lifts, elevators. For that the arrangements are done. See the massive work of timber, massive work of wood. You can see yourself how big it is, how complicated it is. It's too complicated. For the purpose of drawing, not for the purpose of execution. For the purpose of fixing, carpenters know how to fix, but guidance has to be given by the engineer or by the foreman, and foreman is to be guided by the engineer.